Good morning, Calculus 30. Record. What does it mean when you divide? I have a little thing here. Intro. Gazintas. What do I mean in grade 2 talk? Gazinta. Grade 4 talk. How many times does 2 goes into 8? 4 times, that's what I should say. Right? Gazintas. Yes. Talking to a little kid one time, I used to teach elementary stuff too, right? And that's what he called them. Gazintas. Okay. 27. Or I guess 3 goes into 27. 9 times. Okay. Because you should really realize that that's what it means when you divide. How many times something goes into something, right? So, this is just a question. Have you realized this? So, can you have 0 in the numerator on the top? Because every fraction we can consider also as a division question. So, does this make sense numerically? 2 goes into 0 how many times? Can you fit a 2 into 0 items? 0 times. Does that make sense? Yeah, it does, actually. Okay. Because if I was talking here, I guess I'll say, well, 8 goes into. This makes sense for sure. This one a little sketchy, but you can still dream it up, right? I have $2 and I'm going to distribute it to 0 people 0 times, right? Okay. 0 in the denominator, but not the numerator. Why doesn't that make sense? So if I said 8 divided by 0, how many times, 1, 2, 3, 4, 5, 6, 7, 8, 9, not including only the rest of you, how many times can I give each? No. I'm going to reward 8 of you with $0. How many times can I do that? As many as I'd like, right? Reminds me of my Valentine's Day is coming up soon. And my children asked me what I'm getting Mom for Valentine's Day. I said, same thing as last year. Nothing. Now she has a matching set. 0 times. Actually, I love my wife, though. I would get her something, but anyways. This doesn't make sense. You could fit 0 into 8 no times, 17 times, 1,000,000 times. There's no logical answer, is there? That's why we would say this is undefined, right? You can't do this. Undefined. Okay. What does the graph look like when you got 0 in the denominator? Well, what does it look like? Let's think of our simplest question where you have a problem with simplest question, simplest equation, where you get a 0 in the denominator. And we remember back last class, 30, whether you took it last year or last semester. What's the first thing you do when you get a rational equation? Is typically you identify your restrictions, right? This is the simplest one, so your restriction is x can't be 0 because you can't divide by 0. Now, what does it look like as you get close to 0 on the equation? Somebody can do some swooping with their hands, I bet. Does it look like a straight line? Ah, yeah, this is something like that, right? Okay, on the negatives. Skimming along 0, and then it comes out of positive, sky high. Right. You guys remember this, right? Now I'm putting a dotted line over my axis because, well, we could change that shape. However, that's what it goes off into, we say negative infinity, positive infinity, infinity and beyond, right? Okay. That's when you have a 0 in the denominator. If I changed it to something like, and I'll just do it quickly here, y equals 1 over x minus 2. What happened here? It's It's not that different from the other equation, is it? It's a transformation. What happened to that blue graph? Slides to the left or the right? Right, because now x can't be 2. Essentially, you just take this 1, 2, 1, 2, and that's, you know, what you'd have, right? The shape just slid around. Okay, and I won't get into much more. But of course, then if you added 5 to that, it would just shift it up and so on, but it doesn't change the asymptote, vertical asymptote. What about the situation where you get a 0 on the numerator and denominator? I'll make this one easy to see. I'll do the factoring for you. First of all, we have a word for this. If you have 0 out of 0, we have a word indeterminate. That result, indeterminate. Some people want to say determinant, but it's determinate, indeterminate. It's a little different. Do you guys remember what it appears as in a certain case? Now, I'll give you 2 forms of the same equation. I'll give it factor for it. So if we had x squared plus x minus 2 over x minus 1. And we know that x can't equal 1 right off the bat, right? Now if you plug in 1 on this, you notice on the numerator, well, it's obvious we get a 0 on the bottom. 1 plus 1, 1 squared plus 1 is 2. We get 0 to 0 in this case. What could we do to help? When you get 0 to 0, you should be suspicious. There's something more you could do. You could factor the top. And just as a hunch, if you're just guessing and you can't see how to factor it, if you get 0 to 0 on the top with the number 1, because of this, guess that x minus 1 is one of the other factors for this quadratic on here. What's the other one? Well, you can see. Minus 1 times positive 2. Oh yeah, x plus 2. If you're ever stumped. Now, do you guys remember playing around with equations like this? I know you do, Hashim. Yep, and what does it look like when we graph? It looks like the linear equation, x plus 2 with a hole in it though, right? Hole at 1. So, not that I'm going to draw it picture perfect or anything like this, but x plus, well, I say x plus 2. 2 bumps up. I'm not drawing a real scale though, and where I would think 1 is, I'm going to draw a hole there. See my markers off a bit, but whatever. You get the idea, right? That is different. It's what we call removable. So, this is kind of review, right? I don't always expect that everything's memorized though, and stuff like that. So we can have a indeterminate situation where if you can figure out what the common factor is, top and bottom, cancel it out, and graph from there, you're going to have a hole in it. Now what? As I said, holes versus vertical asymptote lines, where the function is indeterminate. Now, don't get too hung up on this is scary stuff or whatever it's all. The function. If the function has a numerator function and a denominator function, meaning some function with x in the top, some function with x in the bottom, and you can factor it out. Common factor of x minus 5, for example, where our case was what? X minus 1. And then there's maybe some other stuff. Where? X minus a. I'll think of that as like my x minus 1. Is not a factor of either what's left over here on the top or on the bottom. And p and q are positive integers. They say like this is squared and this is cubed or something like that. That's what this means. Note that this results in 0 out of 0, which is indeterminate. Now, I gave you a situation where p and q were both 1. They were matching. So completely disappear. Then it becomes easy to graph. There's a hole. So if P, the top power, is pardon me, is greater than or equal to the bottom. We had the equal to scenario. The bottom will cancel. That means, basically, as long as the bottom factor cancels, you're going to have a hole in it. Okay? If it's the other way around, if this was 3 and this was 2, P is, I'm sorry, I did that exactly the opposite. That was what we were talking about. If this was 2 and this was 3, the bottom won't cancel. You'll say all of these cancel and we still have one of those factors. You're going to have a vertical asymptote, dotted line, right? That's something you probably would have logically played around and thought about. Yeah, that makes sense. It's just, I'm going to get you used to seeing some of these things. Don't worry, I won't test you directly on those. But to understand some of those things, when you see rules like that. Because in university, you never know what kind of setup you get for whether you have a good prof or one you can understand easily or not. Sometimes you have to learn from the textbook. We'll see. Don't worry though, you'll have also friends you'll meet people in classes. Now, at x equals 1, whole, vertical asymptote, or nothing? No. Nothing. Okay, neither, we'll say. At 1, and do a test like these are quickly here. I'll get you guys to just try these out, and then we'll check whole asymptote or nothing. You can just test with 1 and just see if you're like that. That's what you think. Okay, B. You plug in 1, at position 1, what would you have? Just an asymptote, right? Could be 1 over 0, so vertical asymptote. Vertical asymptote. Now, this particular one, you're seeing this cancels out. We'd have this left, so that means whole. It's a removable discontinuity. The opposite scenario, the numerator cancels out and this comes down to a square, so it's still there, it's going to be an asymptote, vertical asymptote. Now, just a second here. Good question. Would there be a hole? Well, if you plotted a chart of values, because this agreed that this cancels out to become x minus 3 all squared, right? It seems like, could there be a hole there and an asymptote? There'd be one or the other. There won't be a hole. Yeah, okay. So, by the way, the restrictions you have on anything, why did I put 3 down there? I don't know, x minus 1 all squared, but I guess I was thinking of the old exponent. The restrictions that you have to be set from the way the expression was given originally, right? Okay? So never, you know how like C simplifies and you don't, in the end you get an expression that doesn't have any restrictions, right? Because this x minus 1 canceled. But you have to set your restrictions for the original expression the way it was written. Okay.